let's get started. The sign-in is in the chat, as Dawn has mentioned. So in this session, we will focus on the following questions. What is mathematical fluency? What strategies, methods, and routines can I employ to develop mathematical fluency in my students? And so on the agenda, we're going to first develop a broader view and deeper understanding of what mathematical fluency is and is not. And then we're also going to be next looking at teaching practices, routines, activities, and formative assessments that will promote developing true procedural fluency in students. All right, so our work today is reflective of our high quality math instruction framework that was developed at Wayne Risa by our math consultants. And so this tier 1 ambitious math instruction has 3 different components, the largest component being the math tasks that promote reasoning, but we're not going to be focusing on that today. So our learning today is focused on the yellow area, which is our number sense routine, which is building procedural fluency from conceptual understanding. And then we're also going to dive a little into choosing practice opportunities that will promote mathematical fluency in our students. We also have our work grounded in the research that is from the Math Essential Practices document. So some of you may not be familiar with this document. We have a lot more funding in literacy, as you all know. So you may have heard of the Literacy Essentials, and you may be familiar with those, but we also have Math Essentials that were developed by the Early Math Task Force. One of our math consultants, Christy Hanby, was actually a part of that founding document. And so the purpose of the Math Essentials is to develop a framework of evidence-based mathematics instructional practices to support early mathematics educators in Michigan. And the whole goal is for children to develop agency in mathematics through exposure to cognitively engaging mathematical tasks in language-rich environments in order to advance their understanding of mathematics in ways that are responsive to their social context. Our learning today, though, is going to focus on essential instructional practice number 6. And so go ahead and take a moment to look at the language of essential instructional practice 6. And so although we're going to be looking more broadly at mathematical fluency, essential 6 in our document does talk about number sense routines and promoting mathematical fluency. So before we dive into our new learning, we want to kind of take a look at a context that we're all familiar with as classroom teachers, and that is the context of the classroom. So as you watch this video that I'm going to share, I would like you to let's think about what is the teacher doing and what are students doing as you see an example of a number sense routine going on in a Michigan classroom. Okay, and Dawn, just let me know if the sound is not good. I will pause and make sure I can fix that.
Not hearing any sound right now.
Okay. Sorry about that. Let me go here. And I probably should share my sound first. How about that? Let's try it again, friends. Good? Okay.
Boys and girls, I am going to put an addition problem up on the board for you guys to do for our number talk today. Okay? Remember, when you look at this problem, go ahead and give me a thumbs up when you know the answer to the problem. And when you can explain the problem, put a finger out. Boys and girls, go ahead and talk to your neighbor about what you got for an answer. So who in here would like to explain what they did to get 83 today? Trey, go ahead.
So I knew 2 plus 8 equals 10, so I got 80. Then I added 3 more. That's how I got 83.
Did somebody do it a different way? Rosie,
I counted on.
you counted on. So when you counted on, what did that sound like?
78, 79, 80, 81, 82, 83.
How did you know to stop at 83? Go ahead, Cleo.
This is because 2 plus 3 is 5, and there's 1. There's 2 right there.
There's 2 right here.
Well, 4 right there.
Well, 4.
Yeah. Then there's 2 right there, but there's 6 right there. In that entire line, there's 6.
Okay. So how does 83 work for you?
Because, like Trey said, 8 plus 2 is 10.
Okay, so here's our 8 plus our 2 more.
That's our 10.
There's our 10. And then there's our 3 more. I've got a new problem. Are you guys ready? 78 plus 15. Okay, who would like to tell me what you got for that answer?
93.
93. Jimena, would you like to explain?
So I took 2 from the 5 and put it in the 8, and then I took the 8 and put it in the 7th place, and it was 80, and then I grabbed the 1 from the 15 and put in the 7th place again, and then it was 90, and then I grabbed the 3 more from the 5, and it was 93.
Okay, so you said that there's a 2 and a 3 in that problem. So you said you did the 8 and the 2 to get a 10. And so then you said you added that 10 to the 7 in the 10's place. Okay. And you got 80. And then you said you took the other 10 from this problem to get 90. And then you said 90 plus this 3 got you 93. Okay, then 78 plus 17.
That's a tricky one.
It is a tricky one. You guys can do it though. Okay, what answer did you guys get this time? Ivana? 95. Did anybody get a different answer? Okay, who in here would like to talk about what they did to solve it? Natalia? You counted on. So you did it like Rosie did over here. What number did you start with when you were counting?
90.
Can anybody help where they can see where maybe Natalia got a 90?
2, take away 2 from the 7, that would equal 80.
Okay.
Take 10 away from 17, then that's 90.
Okay, so you said she could get 80 there and then add that 10. And she got 90. So, Natalia, now that you have 90, we used our 78 plus our 10 from our 10 here. We used 2, and it looks like we still have 5 more left that we need to do. What do you think we should do next?
Should add the 5 from the 7 to the 90.
And then what would we get?
95.
Okay, so we can do 90 plus 5 equals 95. Did somebody do this a different way? Johnny?
So I know 7 plus 8 equals 15. And then I added the 1 to the 7, and then I got 80. And then I took the 10 away from the 15, and that's how I got 90. And then I had 5 more now, and that's how I got 95.
I have one more way that when I was walking around, I heard somebody say, and I'm not going to write it down, but I do want them to share. Khalil, can you tell us what you did real quickly?
I did the same. I took it the last way as the last equation.
He used this and he knew that it equaled 93.
So I did the bottom one, just did 93 plus 2.
So he said it must be plus 2 more. Where did you get plus 2 more?
Because 5 and not 7.
There's a 5 right up here.
So I did 5 plus 2 to get to 7.
Okay, and so that's where the 2 came from. He says 15, we do 2 more to get to 17, 16, 17. So our answer must be 2 more than that.
Okay, so let's think about what did you, oops, I'm sorry about that. What did you notice that students were doing or teachers or the teacher was doing during that number sense routine that we just watched? And feel free to either unmute and share, or you can add your answers into the chat. So I see that Sean said the discussion was using multiple methods of getting the answer. Students discuss how they got their answers, and they are using established routines. We also, the teacher was asking open-ended questions that engaged students in discussion in the lesson, and the students understood the meaning of counting on and how to use that strategy. Allowed students to answer in multiple ways. The teacher continued to ask for other ways people got the answer, so we weren't looking for one right answer and then we were done. Everyone was involved in the discussion, asking how someone did it another way. So again, encouraging that it's not just finding the right answer, but about how did we get to that answer. Teacher talk, encouraging how they got the answer, open-ended, guiding students, not providing answers, writing the problem and using the strategy the child used. So that was Kristen. She noticed that the teacher was writing exactly what the student was saying and trying to represent how they had solved the problem. Trying to get a more student-led classroom, using hand signals, listening to all the students when talking to their partners. So you guys noticed a lot of a variety of things. You saw different teacher talk moves. You noticed different classroom management techniques that were happening. You saw evidence of student-led classrooms. So lots of things were going on as we watched this number sense routine take place. So with that in mind, we're going to go forward and we're going to think about our definition based on what research tells us about what mathematical fluency is and what it isn't. And you can kind of think to yourself about what you notice that you saw in the video that also relates to what you see on the slide. So mathematical fluency is the knowledge of procedures, when and how to use them, skill in performing procedures flexibly, accurately, and efficiently. Mathematical fluency is students asking themselves, how can I find? And then choosing from a variety of possible strategies. The students are the decision makers relying on their own strategies. And it's built on a foundation of conceptual understanding, reasoning, and creativity. What mathematical fluency is not is applying a standard procedure or algorithm to every computational problem, even when it is not efficient or necessary to do so. It's not students asking themselves, what method am I supposed to use? It's not built on a foundation of rigid mastery of procedures and memorization of facts. And it's not a reliance on one method for solving all the problems that they encounter. So kind of diving into more of this definition of what is real mathematical or procedural fluency. When we talk about mathematical fluency or procedural fluency, those are kind of interchangeable, but it just means that students are able to apply procedures efficiently, flexibly, and accurately. And so now what I'm going to do is describe for you some actions that students will take if they are showing that they are fluent mathematically. So when students are efficient, they're solving problems in a reasonable amount of time by selecting an appropriate strategy and implementing that strategy. So when they're selecting an appropriate strategy, they have to have been exposed to multiple strategies in order to choose the one that will make the most sense. They practice applying multiple strategies, and they also have to practice selecting between strategies. When we talk about solving in a reasonable amount of time, this is not constant or definitive. It really changes based on the grade level, the exposure to content. So for example, if you were talking about a kindergarten student who was solving addition problems, what we might call a reasonable amount of time would be different than a fifth grader who's been doing this for many years. But what you should not see is students who are stuck, lost, or just not able to move on. They're unproductively struggling with the work. So another action is that when students have mathematical fluency, they are accurate, which means that, yes, they do arrive at the correct solution, but it's not just about a correct answer. It's about implementing either a procedure, an algorithm, or a strategy correctly. I skipped flexibility by accident. It also means when students are mathematically fluent, they are also flexible. So they know all of those strategies. Like I said, they can choose from a variety of strategies in order to apply it to a new problem or a new procedure. And they also know that once they start to apply their strategy, if that one isn't working, they can stop, think about it, go back and start over again with a different strategy. So students can also adapt strategies to fit the current problem. So one way of using a Make 10, for example, might look different when they're in first grade versus when they are dealing with fractions in fourth grade, for example. So what I want you to think about is, what component of fluency do you think that as teachers or as educators, or even as assessors, we most often look for when we're assessing our students to see if they are fluent? Do you think that we're looking mostly at whether students are efficient, flexible, or accurate? Go ahead and enter in the chat. So I do see, seems like the majority right now are saying accurate, but we do have flexible. So I would tend to agree with, I do feel like more than not, we're trying to see if students are accurate. When we give measures like time tests or worksheets that are testing facts, we're trying to see if students are accurate with their answers. So hopefully during this learning today, we can start to kind of shift our thinking about what is mathematical fluency and broadening beyond just accuracy. So what I'm going to talk about now are some misconceptions that researchers have found in the book, Figuring Out Fluency in Mathematics, which I used for a lot of my research for this learning today. Jennifer Bay Williams and John Sangiovanni, 12 fallacies, and then the truths surrounding mathematical fluency. So we're going to touch on each one briefly, but at the end of this learning, we are going to provide, again, like links for the book where you can buy them. And it really would be a great just personal, professional development for yourself, or maybe even for a professional learning community this year. So each misconception, you could spend quite a bit of time discussing and thinking about it. So our first misconception is that fluency is about basic facts. Whereas the truth is that fluency is basic facts, but it's also multi-digit operations. It's decimal and fraction operations, operations involving negative numbers, comparing fractions, solving proportions, and solving equations. Oops. The second misconception is that mastery, fluency, and automaticity are the same thing, when in reality, fluency is greater than both mastery and automaticity. So mastery and automaticity are kind of equal to each other. They both come from repeated practice. But fluency involves efficiency, flexibility, accuracy, and reasonableness, like we had mentioned earlier. The third misconception is that representations are strategies. This one might be a little bit confusing at first to think about, but what this refers to is that strategies are how students think or how they reason about numbers and problems. what visuals or manipulatives are representations. They are tools that students can use to explain their reasoning. So if you think about the context of the number talk that we watched, the students were using their strategies to explain their thinking and their reasoning and how they solved, whereas the teacher was using representations by writing on the board, as some of you had mentioned in the chat. The teacher was writing exactly what the student was saying, but representing it with pictures and with numbers and showing what the student was thinking that way. And so it's one thing that we need to try to help students realize is that their strategies are not their tools that they use. Like using a number line is not a strategy, but it is a tool that can help us explain our reasoning. The fourth myth is that strategies and algorithms are the same thing. So Van de Waal, Karp, and Bay-Williams, they noted 3 different ways that strategies and algorithms are different. So one way that they mentioned was that strategies are number-based and algorithms are digit-based. Secondly, strategies work left to right, while algorithms work right to left, just referring to place value. So if you're using a strategy, you're often thinking from largest place value to smallest, but when you're using an algorithm, you start from the smallest place value and work over. Strategies are also flexible, while algorithms have one correct way. Algorithms also can be learned and followed without really needing to make sense of the problem or to even understand what the numbers represent or mean. And just another note too, strategies are often student driven. So students are able to select their own strategy and use that to explain their reasoning, whereas algorithms are very teacher oriented. It's not something that will naturally come up for a student. They're taught that procedure and then they learn how to follow that by repeated practice and modeling from the teacher. Whereas a strategy is something they can come up with all entirely on their own. The fifth misconception is that once students learn the standard algorithm, this is the best choice. And I know that even I felt guilty to that as a classroom teacher, but you often think that the goal is to get students to the point where they can accurately follow the algorithm and that that's the way to do it. When in reality, standard algorithms are sometimes the best choice, but sometimes they're not efficient. And so helping students to know what types of problems are best for using the standard algorithm and when it is best to use a different strategy promotes procedural fluency. An example would be a problem like 50 minus 48. I'm sure some of you might have seen some of your students do that. If they have a problem like that, they'll still write it down in the traditional way and try to solve it. And then they might struggle with having to borrow and do that. So when really all they had to do was count up 2 to see the difference. The sixth misconception is that standard algorithms are standard everywhere. So we sometimes think students need to know the standard algorithm because that's the way it is in the whole world. But the truth is that different cultures use different standard algorithms and different notations, and even within their culture, they might vary with how they notate math. The seventh one is that some students are better off with knowing just one way. And this comes from a very a kind, loving place, but some teachers believe that if a student is already struggling, sometimes it's better off if they can just learn one way of solving a problem and not be confused with other possible strategies. The truth, though, is that every student is better off knowing a set of useful strategies and learning when each is useful and when they are not. So it might be the case that struggling students have issues with memorizing a list of procedures to follow and what steps to go in the right order. And that might be a struggle for them, whereas they might be able to conceptually understand how to jump on a number line as much as they need to or count on that kind of thing. Also, students that might be more gifted in your classroom, that math might come easily to them, they might also be frustrated by constantly having to practice a standard algorithm, for example, for 2 pages of problems when they understood how to do it the first time. So allowing students the choice of coming up with their own strategies and being able to apply those to different problems is really the goal of mathematical fluency. The 8th misconception is that procedural fluency practice is a low-level, cognitively demanding experience for students So the whole idea of a low DOK, you might believe that, practicing facts is a low DOK. But the truth is that really when we're just remembering the steps of an algorithm and applying it over and over, that itself is a low DOK. A high DOK would be, with practicing procedures, would include judging the usefulness of a method, comparing methods with a friend, generalizing methods. So taking one idea, like how that student noticed that he could use what he'd already done in the previous problem to apply it to the new problem. Inventing a new method altogether, explaining why an algorithm works, making connections among strategies, and checking for reasonableness. All of these are very high cognitively demanding activities that we can do with procedural fluency. The ninth misconception is that first we should learn concepts and then we can learn procedures. But the truth is that students do need to understand the procedures they use. So even after they have a conceptual understanding and then we introduce procedures, we still need to keep connecting those new procedures, new algorithms, and strategies back to the conceptual understanding so that they understand why they're doing the procedures that they are. The 10th misconception is that there is a set list of strategies for any given topic. So similarly to ELA, I'm sure you might be thinking, is there a set list of like phonics rules, for example, that I have to teach my students? Well, the truth is that there are many different strategies that are efficient, useful, and generalizable that belong on a must-know list. And that some strategies that we can teach students, they are maybe less useful and therefore should be optional. So there are some strategies that are better off than others. And I'm going to talk about that in a few minutes. I'm going to go over a few of those. The 11th misconception is that skills tests measure fluency or assess fluency. But skills tests actually almost entirely focus on accuracy, as we had all kind of came to consensus earlier. So when we focus entirely on accuracy, it does not provide a complete picture of a student's fluency. And then finally, our last misconception is that conceptual understanding is more important than learning skills. But the truth is we don't want to just throw out all procedural fluency and just focus only entirely on conceptual understanding. Math instruction needs to be a balance of both. So we still need to practice procedures, practice algorithms, but we also still need conceptual understanding, and it just needs to be a balance. So that was a lot of me talking at you for right now. So far, what we've kind of learned about is broadening our view of procedural fluency to think beyond what we traditionally think of it as just mastering facts and memorizing facts. So now what we're going to think about are what are some strategies for developing this procedural fluency in our students. And then finally, we're going to talk about some different teaching activities or routines or practices that you can try to start incorporating this year into your math lessons to develop that procedural fluency in your students. So what I'd like you to do now is look at these problems on the right. There is the 10 frame, there is the abacus that has partially covered. And then we have the different addition and subtraction, multiplication, and a fraction or division problem. So just go ahead and choose any of those problems that you see on the screen. And I want you to just think to yourself, what is a way or two ways, different strategies that you could use to solve that? I'm going to give everyone a few moments to think about that, and then we're going to share some of our ideas. Okay, so don't feel like you need to have a fancy name for your strategy. You can literally just describe it. Although if you want to give it a fancy name, feel free. But if you don't mind, either in chat or you can unmute and share what is the problem that you chose, and then just tell us what was your strategy? How did you figure it out?
I'll go. I chose the 10 frame, and I guess one strategy would be just counting the dots.
Okay, so you counted, how did you do that? Did you count the top and then the bottom, or did you kind of go, how did you count them?
I did 4 across the top and 3 across the bottom, but then I see I could count by 2s and then have an extra.
Okay, so even as you're thinking through this process, you're thinking, oh, I could have done it in more than one way. Thank you, Elise, for sharing with us. Okay.
Hi, excuse me. Hi, this is Charlene.
Hi, Charlene.
Hi. I do this all the time with my kids with multiplication. So I pick the 4 times 9. Most kids know how to count by 10. So I say, what is 4 times 10? And once they say that, put that answer in their head and count down 4 numbers or take away 4 to get the answer of 36.
Yes. Okay. So you kind of thought to yourself, I'm going to kind of change this problem and I'm going to make it into a 4 times 10 problem. And then because I did 10 4s, I'm going to take back one of those 4s so that I only have 9 4s. Okay.
Mm-hmm.
Yes. Thank you for sharing that, Charlene. I do see people are adding some examples in the chat too, but feel free to unmute if you want to share more. It looks like Dalila said 1/4 of 48. First, she draws a shape and cuts it into 4 pieces. And then she divides by 4 and puts each amount in the fourths. So she seems like she's using kind of a visual, almost like a area kind of way of solving this problem. Angie mentioned that 7 plus 4, she would add 3 to the 7 to get a 10, and then she'd add 1 more. So she made a 10 and added on. Let's see. Oh, Kristen saw the 10 frame, and instead of counting all the red dots, like Elise had done, she counted what was missing. So she kind of turned it into a missing add-in problem, and she saw that there was 3 missing. And so then I'm assuming she would know then that there's 7. Let's see. Kristen said that 1/4 of 48, so she halved it twice. So first she thought half of 48 is 24, and then she thought half of 24 is 12. So she knows that 1/4 of 48 is 12. Kristen must be a secondary or a middle school or higher elementary teacher. I like that. Okay, and then Michelle, you were solving 48. Oh,
yeah.
yes.
Hi, Janine. I just decided to unmute. So
yes, go ahead.
I know this would take a little bit longer or need to happen maybe a little later in the school year, but the 45 minus 18, I would do 45 minus 20 and then, add back 2. So kind of teaching them to look for those groups of 10. I stress that a lot in my 2nd grade class.
Yes, I like that. So you were using, Michelle, a strategy that I think maybe Charlene, or I might be saying the wrong name, someone else used, where they kind of made the problem into a friendlier problem for themselves, right? By using a landmark number. So you decided to do 45 minus 20, but then you knew you had to make that problem equivalent again at the end. So you had to take away 2. Very cool. Carmen noticed on the abacus, she can make an array of 4 by 7. Yes. Okay. I hope I got to everybody. Oh, Elaine noticed that 10s on the 10s frame, she knows that 5 across, and she took 1 away and add 1 more and take 1 away at the bottom. So I think what she means is there was 4 on the top. She could take 1 from the bottom to make a full row of 5, and then she would only have 2 on the bottom. So she was kind of anchoring to 5. Very cool. So based on all of your answers, I would say all of us have a lot of mathematical fluency in this group where we're just using all of these different strategies. I didn't hear anybody say that they used a standard algorithm. We were all using ways that we can mentally solve these problems in our mind, much like our students. Okay. So I don't want to spend too much time on this, and we will talk about this later on if you're interested in knowing a lot more about the reasoning strategies. But the researchers that wrote the book that I mentioned earlier, the Figuring Out Fluency in Mathematics, they mentioned that there are 7 significant strategies that teachers can kind of help students to that they just make sure that they're aware of, that they're exposed to them, and that they see them visually. And so many of us will probably already be very familiar with these. For example, the making tens. We had people that were making 10s in our group. Breaking apart numbers. So using someone even talked about using an array, the halving and doubling, we heard that. So these strategies are like the biggest bang for your buck strategies for students that are able to be kind of applied to many different situations, but some of them are best for certain or are only used in certain operations. And so if I go back for a second, counting on and counting back, this is strictly an addition and subtraction strategy. And then on the side of that, what I'm noticing or kind of bringing to light for you guys is what kind of visuals are best for those strategies. So for counting on and counting back, using number lines, using hundreds charts, number paths, especially open number lines when students can do the jumps that they want to themselves. Those are great visuals for helping students to represent their thinking with these strategies. Making 10s. So this doesn't just mean making 10 like with the most basic facts of knowing all of the friends of 10, but this also means going on into making hundreds, making thousands, making a whole number, making a zero when we were talking about integers and decimals. So the making 10 strategy, some good things for this would be 10 frame cards, unifix cubes, base 10 blocks, circles that we're partitioning into groups. I think that one of our friends that mentioned, using a square and then cutting it up, she might be thinking that way too. Using partials applies to all 4 operations. So those would be like the partial products, partial sums, partial differences, partial quotients that you might have heard before in different curricular resources use those. But when we use partials, it's some of the best representations are using base 10 blocks or algebra tiles to represent that reasoning. Breaking apart to multiply. So that would be when we use either the equal group visuals or the arrays or areas. The halving and doubling strategy, this is best used with the area model. And so that would be best. That's best when there's like a problem that ends with a 5. So for example, let's say you were going to do like 15 times 8. It might make sense to double the 15 to make it 30 and have the 8 to make it 4 so that you're dealing with nice friendly numbers. So you can do 30 times 4 to get 120 instead of messing around with 15 times 8. So that's that strategy. Compensation, this is best used with addition, subtraction, and multiplication. But this, and you can use counters or an open number line or rectangles when we're dealing with area to show how we can compensate. And someone here had mentioned using a compensation strategy, and I believe it was Michelle, when you were talking about 45 minus 18 and compensating by making 18 into 20. So those compensation of, okay, I can move this number, I can break it apart, I can make it into something different, and then I can be more flexible with how I solve it. Using an inverse relationship. So this is with subtraction and division problems, and it's just when the students are aware of how they can use what they know about addition and multiplication to solve. So for subtraction, using open number lines, and for division, using a rectangle for the area model, but with one side unknown. So these are often used with missing addend and missing factor problems. Okay, so I went through those pretty quickly. What we are thinking about next. So we've talked kind of about the number sense routine and how we can build procedural fluency from conceptual understanding using number sense routines like a number talk. But we also want to think about how we can choose practice opportunities for students so that they are able to have those rich opportunities to become more mathematically fluent. And so we have another video to share for you. This is going to be an example of small groups, centers, and games. And so once again, we want you to think about what is the teacher doing and what are the students doing, and just notice maybe how does this relate to our new ideas of mathematical fluency.
Avery, what shape? Ooh, we start off with a toughie.
Trapezoid.
Trapezoid. Sawyer, what shape? Square, Sawyer. How did you know it was square, Sawyer?
4 corners and 4 sides.
4 corners, 4 sides. What's special about those sides?
They're equal.
They're equal. So what's my rules? Do we run? What are you talking about? What are you doing? Math. All right, so Jack and Cass, you guys can be partners today. Joyce, your partner is Mia. Yep. Celeste, your partner is Carly, right? All right, Carter and Emma. What shape did you get? Circle. Okay, how many? 3 circles. What number did you get? 0. All right, so it's Emma's turn. 0 rectangles. How did we know that was a rectangle? Two short sides, 2 long sides. All right, Emma, your turn.
That's what they did it, and I did one. I got 5, right? 4.
So if there's 10 rhombuses total and you just got 5, how far are you?
5.
Yeah.
Here, teach us 5. Oh.
If he has 3, how many more does he need to get to 5?
2. Yeah.
All right, pass your turn.
So those videos that we've been sharing, by the way, are on the early math website. So if you go to mathessentials.org, there are lots of different kinds of videos that are great examples. There is also a module out on EduPaths that covers Essential Practice 5. And I think that their goal is to eventually have different modules that you can get sketches for each of the essentials. But okay, so anyways, what are some things that we noticed in that video of what did you notice that the teacher was doing and the students were doing that are related to our discussion here on mathematical fluency? And feel free to share either in chat or you can unmute.
It seemed like she was checking in with the table that was working on something where maybe errors could take place, where the kids that were working more independently were doing the hands-on manipulative, where there's maybe less chance of an error, which is always the struggle with.
Oops, sorry, Elise, you muted just now. But I appreciate what you were sharing, Elise. So she was mentioning how the teacher had that opportunity to go ahead and check in with different students that were working on activities. And maybe some activities we know are more, it's easier for students to be independent with that work, like using the manipulatives versus maybe some of the content they're going to struggle with a bit more and the teacher might be checking in more often. So that teacher is able to do some of that formative assessment and see how the students are able to tackle problems independently. Valerie noticed that the teacher was asking open-ended questions, observing students as they worked. She asked questions about what students were doing. The students were engaged in collaborating with classmates. Yes. So there was opportunity to continue to talk and reason out loud with their classmates. Lorna noticed that the teacher, her questioning always comes back to, how do you know? To better understand the thinking going on. So it's not about the right answer, right? It's about, how do they know that? How are they reasoning? Kristen noticed that she was able to oversee many groups that were working independently, but in a group with their peers. So maybe there was some peer-to-peer support and learning that was going on. Some other people mentioned the open-ended and the leading questions. So maybe a mixture of both of those. Sometimes we do need leading questions. Asking students why or why not. Using manipulatives. Yes, so using those manipulatives allows students to build that fluency because they have that representation that can help them think through their reasoning. Very cool. Thank you for sharing your ideas. Oops. Okay, so fluency practice is more than a worksheet. So here's some features of high quality practice that you can do with mathematical fluency. So it should be focused. So begin with the accuracy. Whenever students are kind of wrestling with a new strategy, they should have time to practice that in isolation before you combine it with other things. So when we saw like that example of the number talk where students were sharing all kinds of strategies all at once, if they had just learned a new strategy, like how to make a 10, I'm sure that the classroom had a lot of experience of practicing how to make a 10 first in isolation before applying it in different novel situations. So whatever the practice is, just make sure that it's focused on whatever it is that you want to achieve with their fluency. So the different practices are varied. So you can have different DOK types. It doesn't mean that students can't ever practice their math facts. They should. So having sometimes when they're just practicing an algorithm or practicing their math facts, but combining it with times when they have to maybe look at a problem that has already been worked out by another student, or a fake student, just a problem that's been worked out where they're thinking through what was the strategy that was involved? Did it work? Was it an efficient strategy? Was it a good use of the strategy? So type of practice should vary along with type of engagement. So when students are doing things with their peers, or they're playing games, or they're using manipulatives together, that is very engaging. And just having a mixture of that kind of engagement versus times when they do need to focus and be on their own and focus and maybe struggle independently on some work, just the variety of that helps. Students should also have time to process their thinking. So after they have applied a strategy, they should be able to reflect on how that practice went. So getting students to just kind of self-assess and think, was that strategy a good one? Did I use the strategy correctly, or was it not very efficient? That kind of thing. And then connected. So practice establishes or reinforces connections in arranged or sequenced ways so students can see relationships and make connections. So if some of you are familiar with number talks in that book, the number talks actually build sequentially. So you can see how each problem, each sentence build on itself. And so the students you were hoping that they build connections. So that's one example of that.
Another example would be if you have bridges and number corner and you're doing number strings, those are very similar to number talks where they build sequentially.
Thank you, Dawn. Yes, okay. And so types of fluency practice. We have mentioned the number sense routines, which are number talks that we have seen video examples of today, but there's also many other routines that you can do with students that will build that procedural fluency. And books like Figuring Out Fluency in Mathematics. We also have a companion book that is called Math Fact Fluency. And this also has, oh, sorry, it's not showing up very well, but this also has a lot of different routines that are good that you can just do daily and that are short little exercises to do with students to help them build that procedural fluency. Discussing worked examples, like I just mentioned previously in the last slide, and these might be problems that were correctly worked out or partially worked out or incorrectly worked out, but students have a chance to look at the strategy that was applied to solve a problem, and if they believe that it was efficient or accurate or if there was a better strategy that they could use. Games, centers, and independent practice. So all of these are different types of fluency practice that can and should be used.
And you'll see in the chat, I dropped a bunch of links again of different places where you might go to pull some of these practice activities that might be useful to think about planning time for this school year.
Yes. So do whatever you can to save those right now. So these are the books that we relied on heavily for the research and for the activities and our guidance with this learning today. So figuring out fluency in mathematics, teaching and learning, highly recommend, especially for like a professional development that you might do with like a grade level team or in a PLC. Math fact fluency, this one is more of like the old school scholastic books that teachers would buy that are just really, you can pick it up and you can pull out activities, assessments, things that you can use that support developing math fact fluency.
The other thing, the building fluency book with the rainbow kind of color on the front, there are two kind of teacher editions of it, one that's geared towards addition and subtraction and one that's geared towards multiplication and division, that are a little bit more activity based and less of just the research on it, if you're looking for something specific for your grade levels or if you work in intervention.
Very cool. And Dawn, did you already share with them where, like, the links to where they can actually, like, if they're interested in looking later to buy those books? I believe I had it somewhere, but okay. Which is the book for multiplying and dividing practices? She's wondering, Dawn. Do you know if is it still by the same authors?
It's still by the same authors and it's called Figuring Out Fluency in Mathematics. And I think that it has a subtitle, Multiplication and Division. I'll see if I can find the direct link and message it to you or not. And there was one more question. It really depends on your role if we're going to recommend these books and kind of what you're planning on doing. If you are in a teacher leadership role, if you're a coach, if you're a grade level PLC team, I would say the general Figuring Out Fluency book is a great place to get started. If you are a classroom teacher and you're looking to build kind of your intervention and build fluency within different activities in your room and to supplement your curriculum, then the Math Fact Fluency, the purple book, is a really good place to start because there are a lot of ready to go activities that you can use.
Okay. And actually I do have I'm just going to exit out of this for a minute because I have right down here the links, and I will just drop them in chat too. Okay. So we want to offer an opportunity for you to sign in again if you came late, just to be able to get your sketches. If you have friends that you think would benefit from listening to this, they are also welcome to get sketches asynchronously. So feel free to share that. And okay, let me just put this in the chat really quick.
Yep, I've got the links there for the sign in, sign out, and the book resources have been dropped a couple times. Also, I believe when they send the video recording of this, they'll also send all the links we dropped in chat. So we can make sure that these come to you in an email as well. So you don't have to frantically hope that you clicked save and remembered where you saved the chat. So we'll make sure you get all of that information. It will likely come in a recent email in the next week or so.
Thank you.
You need to make sure you signed in. I don't believe that there's a separate sign out, but before you go, we do want to do one more thing with you real quick. Just two more things real quick.
Okay, so we hope that you're walking away with a broader view and a deeper understanding of what mathematical fluency is beyond just math fact memorization, and that you have at least a little idea of some practices, routines, activities, and formative assessments that will promote developing procedural fluency in students.
All right. And
Oops, I'll go back.
If you are interested in learning more, if a number talk seemed very interesting to you and you've never learned about them before, or you're looking for the book or the resource for it, and this yellow sense, that's Essential Practice 6. The RESA course that's most related to it would be one that's number talks, and it is asynchronous. So if you need sketches and you have like about 6, I think, to 8 weeks, depending on if there's a break there, to complete this course, and it'll kind of walk through the basics of what a number talk is, how to complete a number talk. You get a book, you get dot cards, you get a bunch of different resources all mailed to you. If you have a team of teachers that are doing it together, or you're looking for something to focus your PLCs on, this is a great course to consider. And then if we want to jump over to the next component of it, the purple section here, the practice opportunities. If when we were very quickly listing all of those high leverage strategies and different ways that students think about mathematics, we offer math recovery courses. However, we call them MTSS in addition and subtraction, place value and multiplication, and in fractions. And those courses really focus on different student strategies and how students develop their understanding of addition and subtraction and multiplication and division. And so that knowledge as a teacher can be very helpful for formative assessment and really knowing where to go next with fluency. Question about DOK, depth of knowledge. Oh, somebody beat me to it, or like entered right as I said that. So if you're looking about learning more, and I'm going to scroll back on my screen to the slides of what it was officially called here, or Janine, if you've got it off the top of your head, I'm blanking on the terminology that they used. It was after misconceptions. Here we go. The 7 significant reasoning strategies for developing fluency, things like those break apart strategies. The MTSS courses will really help you develop a deep understanding of how students' brains kind of process learning about addition and subtraction and multiplication and division, and that can really be impactful for doing that type of intervention work and thinking about where your students are at with their fluency. And so that's a good opportunity if you're an interventionist or a classroom teacher kind of feeling like, oh, I don't know where to go next with my students. It is very intensive. It's 4 days of learning on a topic, and that's part of why we did a brief 2 minutes on slides of 7 different strategies, and you can really learn a ton more about that and go more in depth. So we hope you'll join us for more learning this year. Please reach out with any questions you have, drop them in the chat, ask us now. We can hang on for a little bit here if we need to, but we totally respect your time. So if you have to go, we understand. I believe all of these resources will be sent to you. If you're interested in knowing more about the Number Talk asynchronous sessions, that would be in our course catalog. I think we have a link somewhere that I can drop in the chat. Or feel free to email Janine or I, and we can make sure you get that as well.
Thank you so much for participating today and learning along with us.